Good morning, good afternoon, or good evening. Today, what we're going to be discussing are Punnett squares, or how we can use this device to go ahead and predict genetic outcomes. You're going to learn today how to go ahead and set up a Punnett square, how to use one, and how to read the results. So, let's go ahead and get started. First things first, things to remember. There are two variations or alleles for each trait. So for example, if we're looking at height, tall, and short, these are passed on from parent to offspring. The offspring will receive one allele from each parent. So for the example we're going to use today, let's look at flower color. So our trait is flower color. Our alleles or variations are purple and white. Purple, denoted by the capital P, is dominant, whereas white, lowercase p, is recessive. So let's go ahead and cross two heterozygous, remember heterozygous is one of each letter, purple plants, so capital P, lowercase p, and see what happens. On the next slide, we'll go ahead and set it up, and you can see how this whole process works. This right here is called a Punnett square. Punnett squares allow us to go ahead and predict probabilities about offspring from parents. This specifically is a monohybrid cross. So currently, we're only looking at one trait, that trait being flower color. So, percentages here. As you can see, we have one parent. So we have capital P, lowercase p up top. And we have the second parent, capital P, lowercase p, on the left. So here, let's go ahead and show you how these line up. As you can see, for our first bit, we went ahead and took this capital P and combined it with this capital P, giving us capital P, capital P. Here, we did capital P with lowercase p, which gave us the heterozygous condition, capital P, lowercase. Now, one thing to note, you can tell with all of our heterozygous, they are still purple because they have that capital P up front, and capital P is dominant. So let's actually look at our percentages for our outcome. So if we take a look and we count this up, you'll notice we have 1, 2, 3 purple right there. So 3 of 4, or 75%, are purple. Regarding the white flowers, there's only one. So 1 of 4, or 25%, are white. How many homozygous dominant? Remember, homozygous dominant, we would be looking for capital P, capital P. And in this case, we only have one. So homozygous dominant would be 25%. How many heterozygous? So heterozygous would be one capital P and one lowercase p. In this case, we have two, or 50%. And finally, how many homozygous recessive? So homozygous recessive, we'd be looking at little p, and here we only have one, so 25%. Now, let's go ahead and do another example of this. So in this case, we're looking for the probability that a couple will have a baby who is a carrier for the A disease. So in this case, healthy allele, or healthy, would be capital A, whereas the diseased allele would be lowercase. Since the diseased allele is recessive, the only way the individual can have the disease is if they have two recessive alleles, or two lowercase a's. Now, a carrier is a heterozygous condition, or a heterozygote. So these individuals, even though they are not sick with the disease, still have the potential to pass on that disease to their offspring. So if we take a look, we have a carrier father and a carrier mother. They're carriers because they have one half of the information, being the lowercase a, or the diseased allele. Here, we have a perfectly healthy baby. Here, we have two healthy babies, but they are carriers, because you can see they have that little a. The big A, or the healthy allele, is going to mask that out, but they could still pass it on. Meanwhile, there's a 25% chance that they could have the offspring with the disease, little a, little a. So let's take this information and try a different example. So for the A disease from the last slide here, remember, capital A is healthy, lowercase a is diseased. So if a carrier man marries a woman with the disease, what potential outcomes for the offspring could they have? Okay, so we have a carrier. Remember, a carrier is a heterozygous condition, so that would be one of each letter. So dad would be capital A, lowercase a. Mom has the disease. So the only way she can have the disease is if she has two lowercase alleles, little a, little a. So we'll go ahead and set up mom on the top and dad on the left. So mom is here on top with little a, and dad is on the side with capital A, lowercase. We're going to go ahead and do the same thing we did with the flowers. So for our first square right here, we'll go ahead and combine the capital A and the lowercase a to go ahead and get capital A, lowercase a. Next, we're going to go to the second one, or the top right, where we have, once again, the capital A and the lowercase. So that would also give us capital A, lowercase, or heterozygous. On the next ones, we'll combine the lowercase a from the mother and the lowercase a from the father to give us little a, little a. And finally, in the last box, we'll combine the last two, which give us little a, little a. So let's talk about percentages. First one we're going to look at is the capital A, or the homozygous dominant. As you can see here, there are no capital A combinations. So our percentage for the genotype of the offspring would be 0. For heterozygous, we're looking at capital A, lowercase. And 2 of these individuals, of the 4, are capital A, lowercase. So that would give us 50%. Meanwhile, the homozygous recessive, or lowercase a, once again, 2 of these 4 individuals could have it, giving us 50%. Now the phenotype being the physical characteristic, would be how many are healthy versus how many are diseased. So remember, if they have the capital A, that's healthy. So we would have 50% that are healthy. Meanwhile, the diseased must have lowercase a, which we have 2 of. So that would also be 50%. Now, of these healthy individuals, how many are carriers? Meaning they could pass it on to their offspring even though they don't appear sick. That would be 100% because both individuals that are healthy are capital A, lowercase. So this just provides a bit of an introduction on how to set up a Punnett square, what variables are what, and how to do the combinations. If you have any questions about this, please go ahead and talk with your instructor. They'll put you on the right path. And until next time, you take care, and I'll see you in the next video.